Okay, so this is just a quick video on graphing linear functions. So linear functions are functions that would be graphed in a straight line. So that's here. So the word linear kind of gives it away because line. So we know it's going to be a straight line. The highest power is just x. So I suppose what I mean by that is there's no x squared and there's no x cubed or no x to the power 4. Like your function will literally be f of x equals 3x minus 8, something like that, because the highest power to this x here is just x. There's no squared up in this box, so there's no cubed, and that's how you know it's linear. So if the highest power of x is just x. So when you graph linear functions, you only need to plot the first and the last point, and like that really makes sense. So if we have our axis here and it's a line, if we plot all these points that give us the line there to there, if we actually excluded them inside points, so let's move that out, exclude that point, let's draw my axis again. So if I just left the first and the last point, that line would be the exact same. So for linear, to save yourself time, by all means you can do it, plot at every point, but to save yourself time you actually only have to find the first point and the last point. So when they give us a question like graph the linear function f of x equal 2x minus 2 in the domain minus 1 is less than or equal to x is less than or equal to 3. Right, we know that f of x means y, so they could present this as y equals 2x minus 2, they could present it as h of x, they could present it as g of x, like we talked about before. That's our function in the domain of minus 1 up as far as 3. So less than or equal to s, less than or equal to 3. This means the values from minus 1 all the way up to 3. So it's all them values, and they're all x values. It even tells you there. So when x is minus 1, when x is 0, when x is 1, when x is 2, when x is 3. But we said that we actually only have to do the first and the last point when it's a line. So that's all we're going to do. And as I said here, it tells you that it's when x is equal to them numbers. So we're only going to use the first and the last point because it's a line. So when we go on to quadratic and cubic, we won't be able to do that. You'll have to use all the points. But for linear, it's first and last. So our function is f of x equals 2x minus 2. So my first point is when x is minus 1. So I'm going to have f of minus 1 equals 2 on minus 1 minus 2. That'll give me minus 2 minus 2, which would be minus 4. So my point, my x, was minus 1. And my output, which is my y, was minus 4. That's my first point. So my last point is going to be f of 3. So 2 times x, which is now 3, minus 2. So that would be 6 minus 2, which would be 4. So x was 3 and y was 4. Okay, so now I have to plot these points. So minus 1 and minus 4. So minus 1 on x, minus 4 on y. So just do a little plot there, point, and then 3 on 4. There. Then get my line. And that wasn't very successful. Which you use your rulers now, and it should be an awful lot better. So it should look something like this. And that's, you've answered their question. Okay, so graph the linear function f of x is 2x minus 2 in the domain minus 1 is less than or equal to x less than or equal to 3. That's it there, okay? But they might ask you some questions about reading off this graph. Now, this graph isn't a really good example because there will be better examples in your book. But this will give you the gist of it. So they may ask you questions like, find the value of f of 1. So we all know that means when x equals 1, because the 1 is in the place of the x. So find the value when x equals 1. So what we do is we go to where x equals 1, which is here. So the graph is just at 0. So y is equal to 0, or f of x is equal to 0. like I said, that's not a great example from this graph, but you'll get the gist of what I mean now in 2 seconds. What have they asked when f of x equals minus 1? So that's when y equals minus 1. So I go to when y on the minus 1 on the y-axis, so which is here, and I read across as far as my line and then go up onto my x-axis to read off the x value. So I would say when y is equal to minus 1, x is equal to 0.5, approximately. So just show you that again. So when f of x is equal to minus 1, so we know f of x means y. So when y is minus 1, they want to know what the value of x is. So I go to minus 1 on my graph, read across until I hit the line that I've just drawn, and then read up to the x-axis. So like, say if they said find the value of f of 3. So that's when x is equal to 3. So I go to 3 on the x-axis, which is here, draw a line up until when it hit the line, and then read across on the y-axis. So y equals 4, or y is equal to 4, x equals 3. If they said when f of x equals 2, find the value for x when f of x equals 2. So I go to 2 on y, because that means y is 2, so here's y on 2. Cross until I hit the line and read down, so x would also be equal to 2 in that case. Right.